Okay, welcome back to the next session of the summit. And it is, as Jun says, my great pleasure to introduce Ihor. He doesn't really need an introduction. He's been with the seL4 team for a very long time, pretty much as long as I have, I think. And he is now at Cry10, and he's going to tell us all about seL4 and Beam, apparently a match made in Erlang.
All right. Thanks, Gerwin. Yeah, so as he said, I'm Ihor. I now work at Cry10. I was with the Trustworthy Systems team before. And this talk is going to be about seL4 and Beam. So you've seen Boyd's talk. He mentioned Elixir and the Beam and so on. What I'm going to do in this talk is kind of introduce a little bit more about kind of seL4's or secure system requirements and how the Beam and Elixir can help provide those. I'm going to talk about some of the technical challenges of getting Beam to work with seL4 and what you need to do that. And then I want to give an example of what an Elixir and Beam-based environment on seL4 looks like. So you've seen a version of this slide before. Our goals at Cry10 are to build these secure, resilient systems. So we have three key requirements: security, kind of presented a little bit differently. We want to have robustness in the face of attacks and at all levels of the system. We want resilience, which is robustness in the face of faults. So we want things to be self-healing, fast, have recovery, minimize downtime, all these things that Boyd talked about. And then I call this usability. We want the system and the platform to be usable. So this means a simple development environment, a large base of trusted software libraries, and something that's a pleasure to use, which we can't really say about seL4 now. But we want to have something on top of seL4 that's really a pleasure to use, that people want to use and are happy to use. With regards to security and resilience, there's kind of three key properties, three key principles that help to lead to these kind of systems. So these are the prevent, contain, and recovers. The first one is prevent. We want to be able to prevent vulnerabilities from being exploited and faults from occurring. So we want to have good software, right? We want to have the software good. We'd like to verify everything if we can. We can't necessarily, but we want to prevent problems from happening. When problems inevitably do happen, we want to contain those problems. So we want to stop attacks from propagating. We want to stop faults from propagating. So even if something bad happens, we want to contain that, prevent that from crashing the whole system or owning the whole system. And then we also need to be able to recover. So once bad things do happen, we need to be able to restart any exploited or faulty components to keep the system running. But we also need to be able to fix the problems, and preferably without horrible downtimes, without bringing the factory line down and causing, thousands or hundreds of thousands of dollars of loss. So these are three important things we need to have. Then we've got seL4. So we all know seL4. And one of the main things that seL4 provides for us is this separation. So we have the hardware and the kernel, kind of the root of isolation. Then we have our user level components running there. And seL4 provides these nice walls between them. We get temporal and spatial isolation between them, which is really good. And that helps solve the contain problem. So provide the contained properties. So if we have any problems in any of these components, they can be contained in there. But what about prevent and what about recover? Well, seL4 is verified, so we've got kind of the prevention there, but we don't really have anything that prevents problems up here, and we don't really have any way of recovering from problems up here inherently in seL4. seL4 allows those things to be done, but we don't have anything that does that. So this is where I'm going to talk about Beam, Erlang, and Elixir as a way of filling those prevent and recover gaps. But I'll talk a little bit about what Beam, Erlang, Elixir is first. First of all, a question for the audience. Who here knows or has experience with any of those? Okay, so a handful more than I expected, but not everyone. All right, so I'll start with Erlang. So Erlang's a concurrency-oriented functional programming language from Ericsson in the late 80s, early 90s, and started for the development of telecoms infrastructure. So as Boyd said, like a lot of the telecoms infrastructure runs on this, a lot of backend infrastructure runs on this, and it needed to be kind of reliable. One of the main things is it's got an actor concurrency model. So this is a concurrency model where you have independent processes that communicate with asynchronous message passing. Okay, so Erlang runs on top of the Beam, and the Beam is the Erlang language virtual machine. Some of the key properties are we've got lightweight processes for concurrency. We've got the asynchronous message passing. It's single-threaded per core. So there's kind of one main thread per core that runs. There's other threads as well. There's support for SMP, so you can have these core threads on other cores as well. It's been heavily optimized. It's battle tested. It's been around for decades in industry, so it works really well. And it's got a really great transparent distribution model, so you can actually run multiple beams on different machines and send messages between them without doing any extra work. So Erlang runs on top of the Beam. And then on top of that, we've got OTP, which used to stand for Open Telecom Platform. It was initially a platform that was developed for building these telecom applications and has grown to more than that, but kept the name. So it's essentially a platform for building large scale, fault-tolerant, and distributed applications. So it's got a whole bunch of libraries, frameworks, patterns, components, tools, and so on that you can use to build these kind of systems, and it guides you in the right way to build these systems to make them kind of large scale, but also fault-tolerant and so on. So OTP kind of sits on top of Erlang. And then we've got Elixir that's been mentioned before. Erlang, if anyone's used Erlang, it's weird. It's got a weird syntax and it's annoying. And I think that's kind of kept it back for a while. So Elixir came around 2012. It's a modern language for the Beam, much nicer. It's got all the Erlang concepts plus. It's got new language features that make programming really fun on it and really easy. I've known Elixir for a long, I've known Erlang for a long time. I only learned Elixir last year. And it's awesome. It's amazing. It's got really good meta programming, and it's got an extensive library which is also shared with Erlang. So a huge library of tools and frameworks and packages and stuff like that out there. There's dependency management and stuff like that. Makes building for this kind of ecosystem really amazing. So Elixir sits on top of that and can use all of the OTP and Erlang functionality and Beam functionality, which is really good. And you can mix and match Erlang and Elixir. And then all of these have a huge community, a great community. So there's a whole bunch of international meetups, a whole bunch of international conferences. I'm going to talk at a Beam conference in a couple of weeks at the Computer History Museum in Mountain View. There's a bunch of development companies that specialize in building kind of Elixir, Erlang-based systems and so on. And people really like using it. So recent Stack Overflow survey showed that Elixir was the second most loved language by developers, with Rust being the first one, obviously. And it's got really popular frameworks. So the Phoenix framework, it's a web framework, is the most loved framework for people to work with. So it's really growing. It's really got a lot of momentum, and people really like using it, right? So this kind of that usability aspect, like it's a pleasure to use. So how does it feel? How does the Beam fill those two gaps, kind of the prevent and recover gaps? Well, Beam helps to prevent problems. So we want to prevent faulty software within seL4 protection domains. Well, the language itself is good. It's better, it's easier than C. It's a functional programming language. It has, memory protection in that way and so on. There's a nice language. There's a lot of frameworks that help you actually build good systems. So they guide you to build good systems. We've got the dependency management, the tools and stuff. It's got a really good concurrency model. So this is a concurrency model for within an seL4 domain, but you can also use that kind of concurrency and communication model outside of it. So it's got this actor-based communication model, so asynchronous message passing model for communicating between beams, for example. So you can use that for communicating between seL4 domains. And we've got like a lot of nice frameworks for building up communicating systems. So this helps us a lot. And then there's this isolation aspect. So within kind of an seL4 protection domain, you've got memory isolation through the Beam model and the language model. There's no, by default, these processes, these lightweight processes that the Beam and Elixir and Erlang have, don't share any memory. So they're really kind of independent processes, and that gives you this memory isolation. And so that helps to build good systems and helps to prevent a lot of the problems. And then the other thing that Beam helps us a lot with is this recovery aspect. So being able to recover from faults within seL4 domains, right? If one of your seL4 components crashes or has a problem, how do you recover from that? Well, again, we've got these lightweight processes. And so we've got this process independence. They don't share memory. And so if one Beam process crashes, it's not going to take down all the other processes, and it's not going to take down the Beam virtual machine itself. It's just going to crash. Everything else is going to keep running. So we've got that. You write some bad code, it crashes. It doesn't kill everything else in your seL4 domain. But it's also got error and crash detection. So you can actually link and monitor these processes together so that if one of the processes does crash, another process can be informed of that and deal with it, which is really good. And they build on that with this idea of supervision trees. And so you have this kind of tree, this hierarchy of supervisors and processes. And a supervisor will be notified if a process crashes, and then it can decide what to do with that. And there's built-in default behaviors, for example, to just restart it automatically. So a process crashes, it gets the supervisor notified, it gets restarted. Or you can restart all the processes that it's related to, for example. Or you can decide to not restart it, or you can restart some subset of processes. All of these are pre-existing kind of behaviors that you can easily use in your system. So you get this great recovery. There was an aspect of being able to reload code at runtime without bringing down the machine and so on. So it gives us a really good model for doing the prevent and the recovery part of things. So that's really great, but we actually need to get this to run on seL4 and integrate and play well with the rest of the seL4 system. So the main challenges are just running the Beam on seL4, right? This is the biggest challenge with seL4 in general, running software on it. We need to also take advantage of this communication. The Beam just running by itself is not that interesting. It becomes interesting when it can communicate with other things running on the seL4 system as well. So we need to communicate outside the Beam, both to native components, your drivers and stuff like that, but also between Beam instances. It's nice if you can run a bunch of Beam virtual machines, do the isolation, and then still communicate between them. And then we want to take advantage of this Elixir-based development and create a whole development environment for seL4-based systems. So we want to be able to develop most of our application or business logic in Elixir. We want to use existing libraries and frameworks. We want to use the nice tools that are out there for actually building our system, managing dependencies and stuff like that. And we really only want to touch things like C and Rust and CMake and so on for the really low-level things, the really low-level system things. And everything else could just be Elixir, and you can get a lot of developers in there that don't necessarily have experience with C, Rust, CMake, building OSs and stuff, building systems that can run on seL4. Those are the challenges. So the first one I'm going to talk about is, what do we do to get Beam running on seL4? This is what it looks like. So we have kind of these big blue kind of oblong boxes are seL4 protection domains, processes, components, whatever you want to call them. And this is the Beam one. And this white box here is the Beam code. And we just use the Beam as it is. We don't, we just take the Beam, compile it, and use that. It consists of this Beam scheduler, which is essentially that thread that runs. And then all these lightweight processes, and the scheduler just chooses which one to run and runs these processes and does all the multitasking, basically. We've got things called dirty schedulers, which are for blocking work, for I/O and stuff like that. And then Beam is extensible by adding these native functions and port drivers. So you can add your own kind of C code into the Beam to do special things, right? But these are not protected. If these crash, the whole Beam crashes. So you want to avoid adding that code as much as possible. The Beam is built to run on a POSIX-like system, so we need to have some sort of POSIX-like functionality underneath that. The main thing is threading, because it's got these kind of scheduler threads and dirty threads. We need some kind of basic file system functionality to actually load the code. We need some POSIX-type syscalls, and then we need a network stack as well. And then outside of the Beam, we've got a bunch of kind of components and mostly drivers that it relies on. So networking, serial, clock, random number generator, and something to do logging and so on. And all of that runs on seL4. So what we needed to do to get the Beam running was kind of this lower layer that it depends on, and all of these kind of native processes alongside of that. Once we get the Beam running on it, we needed to communicate with things. So the first thing we wanted to do was to get it to do seL4 IPC, or communication, inter-process communication between the Beam and native components, so it can use all of these kind of drivers and things like that. So the basic approach to that is you write this port driver, which is this native code that you inject into the Beam that knows how to do seL4 system calls, and it can communicate over endpoints. It can allocate shared memory. You can kind of create your own channel with a C component that has its kind of reply receive loop, and you can talk with that. So that's the basic way. It's kind of very non-transparent. You're obviously talking seL4. So the thing we needed to do for that was write this seL4 port driver, so this native code for Beam. Otherwise, it just works. The other thing we want to do is if we have multiple Beam instances running on top of seL4, we want to be able to communicate between those. So there's kind of two ways of doing that. Beam allows us to write, so Beam implements a distribution protocol. So a way for Beam instances on different machines to communicate with each other. And that generally works over TCP/IP over a network. And so you can, over a network, connect Beam machines together and they can communicate together. And this is implemented by kind of a distribution protocol, but Beam allows you to write your own distribution protocol carrier. So what we can do is write our own distribution protocol carrier, use our own port driver to do seL4 or Crichton OS communication, and then use kind of our endpoints, our message server, our shared library to implement that communication. So we can do that, and that involves writing all of this code and inserting it into the Beam. That's one approach, but it does involve inserting our own code into the Beam, which could crash, right? I mean, we're good programmers, but it can crash. The other approach is to take advantage of the existing TCP/IP distribution protocol that's already there, which is battle tested, that's been used a lot, and basically implement our own kind of simple network server running on seL4. So we kind of go through TCP/IP here, which just forwards it along to the other one. That's another approach to do it. It doesn't require injecting any code into the Beam and stuff. This is just using Beam straight as it is. We have kind of a simple network server here that just kind of forwards things along. It's basically a loopback server. So those are kind of the ways of doing that. Otherwise, we want to take advantage of the Elixir environment. So we want to build things, our apps on Beam with Elixir. There's a huge library called Hex, a package manager that relies on a library of a whole bunch of things. A lot of the code and the packages in Hex work out of the box on Beam on seL4. So there's a huge library of things that we can use and take advantage of. For example, HTTP clients, TCP/IP libraries and stuff for communication. We've got the Phoenix Web Framework. This super popular framework can just run on Beam on seL4. We've got, Boyd mentioned the UI, the scenic UI. We've got even drivers that are written in Elixir for kind of IoT sensors and stuff like that, small devices that you connect to your boards. And we've got the interactive Elixir shell and so on, and all of that kind of works, and we can take advantage of all of that. And then we want to be able to actually use the development environment to develop as well. So we want to be able to develop application logic for a system only using Elixir, so not touching any of that C or Rust or CMake or anything like that. We want to use Mix, which is the Elixir build tool, which gives us commands like mix new, mix compile and stuff. And then what we've done is kind of adapted or extended Mix because it's extensible to have KOS specific calls for building our seL4 cost-based systems. So that's what we want. So I'm going to do a demo now. Conventional, knowledge is that you don't do a live demo at a presentation, but YOLO. So here goes nothing. All right, what I want to show is how to build an seL4 Crichton OS build-based system just using Elixir and Beam and what some of the properties of that are. So I start off here. Forgive me, my typing skills are terrible, especially if I'm doing this. Forget everything. All right, so what I start off with is this. This installs kind of our extensions to Mix so that we can do stuff. And then, I'm starting a new system here that I'm building. And then I can sorry, and you do this. All right, try again. I actually have to go into the directory it created. So this will bring down or prepare, in any case, all of the seL4 and KOS stuff and so on. Oh, come on. All right, so this is going to build everything. Give me a couple of seconds for that. And then, yeah. Yeah. All right, so, all right, and then I'll run it. So this is opening up another terminal here. Let me just dock that in here. I'll increase the font a little bit. So this is a system running. So it's booted up, it's run, and it's essentially connected to this management server that Boyd talked about. We call it Orbit internally. So let me show you what that looks like in my browser. So I'm running this locally on my machine. So I log in to this management server. All right, so I got a project. I go to a project and I can look at a deployment. And this shows me all the devices and it shows me which one's online. This is the one I just started, which is online. So I can go there, get some information about it. In particular, there's some operations I can do on it. So I can ping the device and just check that it's alive. The cool thing, so Boyd showed a little bit of this. I can show the manifest. So this is what's running on the device. Can't really see it that well. Maybe, I don't know how to scroll. Okay. So we've got kind of a Ethernet driver there. We've got a tunnel there. We've got this admin component, which is another Beam instance that's running, that's actually talking to this Orbit server that does all the administrative stuff. We've got some of these servers running there, RNG, logging, and this loopback and stuff like that. But we can like click on here and kind of get some information about some of the properties of these things. So that's really cool. Let's see, let me dock this to the side. Okay, so we've got this system running. What else can we do? We can add some Elixir applications to that. So we can, okay. So, sorry, forgot the directory again. All right, so we go into the directory, we create a new application. Let's see. Oh yeah, so this brings in some dependencies, so we can pull in our dependencies, and then we can create another application. Okay. I'll just open up my browser in here, or my editor in here as well. Increase that. Could look at kind of what we've created. The main thing is we've got these apps here. We got our system defined, but we've got our applications. It's kind of using the mix build system, so there's a build file. But the interesting thing here is our Elixir code. So we got this application code, and the main thing is here we're starting a supervisor. We're starting some other applications, in particular this my app Echo, which I'll show, and a supervisor. And I'll get back to that a little bit later. And then we've got our Echo, where this is kind of really simple Elixir code. It's got an Echo server where it receives a message, it'll print something out, it'll log something, it'll send a reply back, and it'll go back to it. So it's just going to loop doing that. And we'll see that in action in a little bit. All right, so what next? Okay, let's build this new system. Okay, so wait for it to finish building. Okay, so it's built. So rather than restart it, I want to show you something cool here. So we can just do an upgrade through Orbit. So we'll choose system upgrade. I'll choose a file that's just been built. So this latest.zip is kind of a zip file of everything we just built. I'll put it in here. Click system upgrade. It's going to upload it over the network to to there. So that's there. While it's going, it's going to update a bit. I want to also show you this. So Boyd talked about kind of security in tunnels and stuff like that. So we look at some of the information about the device, and we see a bunch of keys here. So we've got this key. This is essentially a wired guard key. We've got a tunnel where all the communication goes through a wired guard protocol tunnel between the device and the server. And so this is encrypted with keys, and it also helps to authenticate the device. So only like actual devices that you trust, that you own, for example, can connect. We've also got these other keys that help to identify devices for other purposes as well. And you can change these settings if you need to, and so on as well. All right, so back to our system. So it looks the same, but what's actually happened is that we got this request from Orbit. So this was where it was running previously. We got this request, and it told it what files to transfer. And then it looked locally, and you can see it saying loading cached images. So it actually doesn't have to download any images that haven't changed. These are stored locally on local storage. So it loads those back from local storage. And then there's should have been 2 images, here. The 2 VDSOs, which are the kind of the deltas to the beam images, were downloaded over the network. And now it's running here. And we can see that we've got these 2 new applications started that weren't there before. So yeah, if we look at the code, let's see here, we see it's got this output of my application starting. So these applications are started now. All right, so I'm kind of over time, but there's a couple of awesome things I still want to show you, which is how the communication works. So in order to do that, I'm not going to modify and compile code. I'm just going to go into the interactive shell. So this is a shell. It's connecting to the Beam instance that's actually running on the device. And you can send commands to it, so or run code. So this is actually going to be running code on that Beam itself. So one of the simplest things I can do is use the logger to send a message. And that message gets printed out here. I don't know if you can read it, but it basically has the name of the app and then the message that it prints. So that uses the logger. That's actually sending messages to a separate component running on the system. So here I bring in my cheat sheet and kind of show you how that's done. So we open a connection to that component. So it's publishing a protocol, so we connect to that protocol. And then we create kind of this data structure, which is the message we want to send. And what that's basically doing is it's kind of encoding these Elixir data items into C representations of that. And then we're going to send that to our server. So remember, this is all running on that Beam instance. And so, darn it. Yeah, so we see we got this new message from the logger again. So that was a longer way of doing what I did previously. The previous code just wraps all of this up nicely. But what we can do as well is we can do raw seL4 calls as well if we want to. So if we have something that's an seL4 system that's implemented that doesn't use the Crichton protocols, we can do that as well. So, okay, here's some kind of code that that's there. And basically we have, what are we doing here? seL4 call. We've got this weird number, which is basically a cap reference. You get that because you put a print into your code that prints it out and you know what it is. And then we create a message info with a label, and that's just a command saying that we want to print something. And then we've got this Elixir string that we're translating to binary. That puts it in a message. We send all of that to seL4, and gosh darn it. So we see that seL4, or the serial server, in any case, prints this, right? So we just sent an seL4 message to the serial server, which is cool. The last thing, or the second last thing I want to show you is this communication between Beam instances. So we can look at what our node is called. Let me push that up a bit. There. Anyhow, we can call node, and it tells us our node name. We can see which nodes we're connected to. We're only connected to the IEX instance, but we can connect to other nodes. So we connect to the other node as well, and then when we list the nodes, we can see that we're also connected there, which is cool. But we can also send messages between nodes, or we can even start processes on other nodes. I won't start the process now. What I will do is I'll show you how to just send messages between them. So if you remember our code, we started this application, and it runs this echo server. So we're now going to send a message to the echo server. It's going to log what it receives and then send a message back. So this is now from one Beam instance sending a message to another Beam instance. And we see that the logger has indeed logged that other app got a message and printed it out. And then we can also receive the message. The easy way in the shell to receive the message is to just flush. And so we receive the reply as well. So this is the inter-beam communication working. There's kind of a question of, well, if you can communicate with any other beam, can you also send messages to the admin component and essentially abuse that to crash the system or crash the admin component? Because the admin component has the functionality and the ability to restart the whole system. So let's try that. We're going to send it to admin, which is the admin component. We're going to just try to log, but it refuses that because these beams don't have a connection to that component. So this is one of the benefits of running on seL4 is that you can, and Crichton on is you can limit the connections between components. And so this uses that isolation to say, no, regular Beam instances that run some user code can't talk to the admin component and actually crash the system. But the Orbit server, for example, can talk to it. Last thing, promise, is some of the cool tools. Because we can do this beam-to-beam communication, we can take advantage of tools that are written for Elixir that already use this beam-to-beam communication. So what I want to show you is the Observer, which is a built-in Elixir app, and it throws up a window here. Let me just, all right, that's good enough. I don't know if it'll increase. All right. What this shows is what's running on the system. So in this case, this is showing me what's running locally on my laptop in terms of a beam. But if I'm lucky, I can connect to the beam instance running on my device, actually. And it now shows me information about my device. So it's telling me how many threads I've got, what version it is that's running on COS Linux, etc. Other cool things we can do is, you can do memory out, see what the memory usage is, what the load is and stuff. You can see a view of kind of, I'll show you that in a sec, of the applications. You can see a list of the processes running, and so we can kind of scroll down and find our echo process, and we can get process information about it, what it's running, what messages it's receiving. We can see its stack trace and stuff like that, so we can do really cool inspection of stuff. Coming back to here, so this is our application that's running on it with the supervisor. So this is the supervisor, and this is my echo function or server, and this is the port driver for the KOS messages, and this is the port driver for the seL4 messages. One of the things we can do is look here, and okay, this is a detail. At the bottom, you can see this process number. It's 121 is the process number. What we can do is we can kill this, right? So my echo server, I can kill that. When I come back, this process number has actually changed. It's 215. And so it's been automatically restarted by the supervisor. So I can crash things and it just gets automatically restarted. And then I can go back to kind of, my system's still running, and I can do my, still use the echo server, so I can still send messages to it. Let's see. Yeah. And everything still works. All right, so done the demo, done the presentation. So the summary is we want to prevent, contain, recover. seL4 helps us contain. Beam and Elixir will help us prevent and recover. Beam runs on seL4. We can do communication stuff, and we can just do full system development in Elixir on Beam. Thank you.
Thank you very much. That was too cool to cut off. So there's time for one question, which I guess goes to Gernot.
Nice stuff. You were suspiciously quiet about performance.
Yeah, so we haven't optimized for performance right now.
So what does your networking throughput look like?
I don't know. Do you know any numbers, Kent, on the throughput? Yeah. Sorry, what are you saying, Kent?
The first answer was good enough.
I said it was good enough, and then I said it's control plane, and then I said every time I try to say I should spend time fixing performance, I get told it's less critical. Like it's, I don't know what I'm trying to say. It's like 100 megabit. Like it's the performance isn't a bottleneck in the system, so it's not. We haven't really spent time trying to optimize it.
But at the same time, like it is running on seL4, and we look forward to like the driver framework work, improving things. We also look forward to the U-boot drivers and stuff like that to help us develop systems, bring things up, find out where the pain points are, and improve those.
Okay, thank you very much. Thanks to Ihor again.